Okay, so I got my act together and I've got my calculator ready, and we're going to do this much more quickly with this video. So let's take a look at numbers 3 and 4. On this, I've drawn the two triangles already, and so all we have to do is figure out how to compute these. This is going to be a law of cosine situation because we have no angles to compute the to be able to compute anything with. So let's figure this out. Alpha and beta will be the same because these two sides are the same, and so they'll be the same measure. So we'll pick one of those because those will both be bigger than gamma. So let's do alpha. So you have a squared is equal to b squared plus c squared minus 2bc times the cosine of alpha. And so using the numbers we have up there, I have 20 squared is equal to 20 squared plus 10 squared minus 2 times 20 times 10 times the cosine of alpha. And we'll just do some simplification here. Let's see, I have 100, negative 100 on the left, and negative 400 cosine of alpha on the right. Okay, so just so you know what I did, I canceled those. I moved this over. And I computed 2 times 20 times 10. And then that gives me 1/4 when you divide. So alpha is equal to the inverse cosine of 1/4. Let's go find out what that is. I did it on my calculator already. I've got alpha is equal to 75.522. And then we can easily figure out, I guess this is 522. We can figure out that, what did I say was the same? Alpha and beta are the same. So beta, using the same exact calculations, because all you've done is you've just switched the A and the B. So if you switch those, everything else is the same. You get the same exact thing. And then, of course, to get alpha, it's a pretty straightforward 180 minus 75.522 minus 75.522, and that's going to give me gamma. And that I did. Just a minute. Oops. There we go. So that's 28.95. 55. I guess that got rounded. How about that? Makes me feel better that it works out. Okay, so that's pretty straightforward. Whenever you have 3 sides, you'll use the law of cosines to find the bigger of the 3 angles. In this case, there's a tie. And then if you want to, you can use the law of sines. In my case, because I had 2 of the same, it was easy to do without that. Anyway, let's take a look at this one. This is a law of sines problem. So number 4. And to do that, what we'll do is we will first set up the law of sines, perhaps to get, it looks like I've got that angle and that side. I have this angle. I need to get this side. So that's sort of the way I think of this in my head. I sort of visualize the opposite sides from each angle. And so I'm going to do the sine of 50.83 over b is going to equal the sine of 70.58 over 537. Doing some rearrangement, I end up with b is equal to 537 times the sine of 50.83. This is after a little bit of algebra. Oops. Okay, and then did I do this one? I did do it. That ends up being at least what I've calculated. Law of sines, 50.83. Just want to look. Wait a minute. Is this 70.58 or 53? 70.58. Okay, so I see I did a minor mistake, and now I will fix it. Okay, 441 0.44. So whatever that is. And then the other, so then you're going to do 180, so alpha minus 70.58 minus 50.83, and that ends up equaling 50, what do I have here? 58.59 is that angle there. And then the final job that I have is to compute A. And so you have sine of 58.59 over A is equal to sine of 70.58 over 537. After a little bit of rearranging, 70.58 okay, over sine of 58 point, oh, I blew that. Sorry, I got distracted. 58.59. And then this is 70.58. There it is. And that one I did earlier as well. And I got 485.96. Yeah, so it's quite a bit of work, even with the additional work that I did off camera, so to speak. Okay, we'll do another video for the next one.